Oh, so are you saying that okay, I don't know if I'm correct, but in a neutral charge, it just means that the protons are equal to the electrons. So
Exactly.
so if we
Exactly.
oh, okay, I get it.
Momson, did you hear what she said?
Yes, I heard what she said.
Do you now agree that there will be attraction?
Yeah. Yes.
Oh, okay. So if I bring an object which has +5 microcoulombs, will they be attracted to one another?
Yes, sir.
Yes, sir.
Okay. Through the phenomenon called charge polarization, because the positive charges will be repelled and they will come to this side. You agree?
Yes.
At the same time, the negative charges will come to this side. The reason why I drew 3 negative charges and 3 positive charges is because a neutral object have the same amount of positive charges as there are negative charges. We agree? Okay. So the other point on electric field lines. Ronewa, do electric field lines, are they allowed to cross each other?
No, sir.
They do not cross. Okay, what's the other point I can emphasize? Okay, the closer the lines, the weaker or the stronger the electric field, Mamswa.
The stronger the electric field.
The stronger the electric field. Okay, that's correct. And what's the other point? I think that's about it. Okay. The electric field between a positive and a negative charge. Okay. Now, actually, I'm just gonna draw random electric field patterns, and then I would want you guys to identify which one is which. Now I'm also breaking the rules. I don't want to break the rules. Perpendicular. Perpendicular. Let's see. Perpendicular. 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 We join. Perpendicular. 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 Okay. Perpendicular. 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 They join. Perpendicular. Join. That's not what I wanted to draw. Okay. Between the two, Romeo, what is the sign of this sphere right here? This one.
So, is it negative?
Mamswane, what do you think?
So it's negative.
Negative. This one is
Positive.
positive. So if I put a test charge there, obviously it will be repelled by the positive and it will be attracted by the negative. That's perfect. And this one will be
Positive.
positive and
Another positive.
positive. I think you guys understand these electric fields. I don't think there's anything new that I can try to trick you guys. Oh, okay, but okay, let me just ask this one. Okay. What? How do we calculate? It's a classic. How do we calculate the electric field at this point? E total, which one is correct? E1 plus E2 B. E total equals E1. C. E total equals E2. Or D. E total equals E1 minus E2. Which one is correct, Ronel? On this one, for the first one, for the first case, which one is correct? If I'm calculating the electric field at this position.
But I'm just gonna give you a wild guess, and I will say A.
Mamsane?
So I also think it's A. But
That's
don't we
correct.
have to like?
Don't we have to?
No, I wanted to ask if we don't have to choose direction or anything.
Yes, we have to choose the direction. If I put a test charge there, the first force, okay, do you agree that the minus will pull your test charge? That's the first force, or that's the first field. It will be in this direction. Do you agree?
Yes.
And then the positive charge also will push it in the same direction. So to get the effective field, we just add the two because they are going in the same direction. Okay, so if I am analyzing the field in this direction, which one will be true? Ronel.
So, would it not be C? No. D. I'm gonna say D.
Mamsane.
And you talking about the second diagram,
Yeah.
right?
No. On the first diagram, but if I put a test chart there, or if I analyze the electric field in this position, which formula am I gonna use? A, B, C, or D?
I think you're still gonna use A.
Unfortunately, Rondewa is correct. Rondewa is correct. You're not gonna use the same formula because if you put a test charge there, the negative charge will pull it. You agree?
Yes, yes.
But the positive charge will
Repel.
push it away.
Okay.
Then after choosing the direction, if you choose this direction as positive, then this will be your E1 most. E1, which is positive, then minus your E2, which is the one, which is the positive, because the positive charge is repelling your test charge. So the answer is D.
Okay.
So the electric field strength between the two charges and the electric field strength outside of the charges is different. So when it's outside of the charges, you're going to have to subtract because the direction of where your point charge will be pointing will be different. Okay. Now let's go straight to the question. Ronel, what is the principle of conservation of charge?
So the law states that charges cannot be created or destroyed, but they can be transferred from one object to another.
That's correct. Or destroyed. Okay. Calculate the charge. Okay, let's see what the problem says. 3 identical metal sphere, A, B, and C, carry the charge of minus 2 times 10 to the power of minus 11 coulombs, plus 6 times 10 to the power of minus 11 coulombs, and minus 5 times 10 to the power of minus 11 coulombs, respectively. All the 3 spheres were brought into contact with each other and then separated at the same time. Calculate the charge on each sphere after separation. Roneo, how do we go about this one? What is the formula? So this 5.1.3. What is the formula? The 2 spheres were all brought into contact and then separated.
So I don't know.
Mamsani, what is the formula of calculating the charge on each sphere after separation?
So will we not say Q nu is equals to Q1 plus Q2 plus divided by 2 plus Q3 divided by 2?
Plus Q3.
No.
I knew the trick. I knew this was going to be a trick.
Oh, there are 3 charges.
Do you know why we added the 3 of them? Because the 3 of them, during contact, the 3 of them became 1 because they are now in contact. If you bring 3 spheres together, they will become 1 object.
Okay, so that's fine, but why did we put it over? Did we put it over 2?
Over 3.
Oh, okay.
But do you agree with the 3?
Side the 3.
Yes. So if we had 4 spheres, what was going to happen? Mam Swan, what will be the formula?
Q nu is equals to Q1 plus Q2 plus Q3 plus Q4 over 4.
Exactly. So once the three spheres become one, it means even the charge between the union is the same. That's why we have to add all of them. So when they now separate, it means that entire charge we had is now being splitted into three different parts, into three equal, not different, into three equal parts. So the reason why the charges are equal is because we have three identical metal spheres. The sizes of the spheres are the same. And in your syllabus, you will only gonna be dealing with identical metal spheres, unfortunately, which are hanging on top of an insulated stand. Why does the stand has to be insulated, Romeo? Why does the stand have to be insulated?
So I'm not sure why, but does it have something to do with the fact that it shouldn't attract any of the charges?
Okay. What is the difference between a conductor and an insulator, Mam Swan?
And doesn't an insulator ensure that what is an insulator actually?
An insulator is the one that it prevents the flow of electricity through it, and then a conductor allows for the flow of electricity through it.
Yes.
Okay. Thank you.
Yeah, so why do you think the stands should be insulated, sorry, Mam Swan?
So I think so that it does not get attracted to the charges.
Okay, the answer is to not allow the charges to escape from this system. Because if we had a conductor, remember this, the stands are put on the ground, and the ground is usually charged. The ground is usually charged. That's why when there's storms and rainfall, there is what we call lightning. Lightning is caused by the charge on the clouds and the charge on the ground. So the insulated stands prevent the flow of electrons from the sphere to the ground. Are we together? Because if there was a conductor, electrons were going to move through the conductor. And that's what we call current. Current is the flow of charges in the conductor. So we are preventing the flow of charges inside the stand. Okay, that's a story for another day. Calculate the charge on each sphere after separation. The first one is minus 2 times 10 to the power of 11. So it's 265. Let's see. divided by 3. So how much are we getting? I don't have a calculator. Let me see. How much are we getting?
So I'm getting 2 times 10 to the power of 11.
2 times 10 to the power of minus 11. And the unit is coulomb. And okay, what will be the charge of A after separation, Rondell?
So I have a question there, but in the calculation, is it 6 times 10 to the power of 11?
Minus 11, sorry.
Okay, so but that's gonna give us a whole different answer.
Okay.
Okay, then the answer is gonna be negative 3.33 times 10 to the power negative 12.
Negative 3.33 times 10 to the power of
Negative 12.
minus 12.
Yes.
Mansani, did you get the same?
Yes, sir.
Okay, no problem. So what will be the charge of sphere A after separation? This is
So
sphere A. Yes.
would they all not be equal to each other?
Exactly. So I was trying to see if you still remember grade 10 concept. Okay, let's go to the next question. By calculating the charge of sphere B, explain why sphere B becomes negatively charged after contact.
So for this question, have we
Yes,
not already calculated the charge of sphere B, because we said that all of them after contact, like, they'll be equal?
that is true. But the instruction said by
Calculating.
the change in charge.
Oh,
So we must demonstrate the change in charge. So what is the formula of calculating the change in charge, Ronel? That is 5.13. What is the formula of calculating the change in charge? What is the formula? Mamswan.
Sir, I do not know.
What is the formula of calculating the change in charge, Ronel?
I also don't know.
Do you remember this formula from grade 10?
Oh, yes.
Okay. So Q final is minus 3,3 times 10 to the power of minus 12. Then what is Q initial, Ronel? They are talking about sphere B, by the way.
Is it
So
not
what will be?
positive 6 times 10 to the power negative 11
Yeah.
coulombs?
So okay. Positive 6 times 10 to the power of minus 11. So what is it that we are getting?
So I'm getting negative 6.33 times 10 to the power negative 11.
Coulombs.
Coulombs, yes.
So yes, so this is the amount of charge that was brought into sphere B. The reason why it was brought is you can see that the sign is negative. So the change in Q happens to be negative. It means there was electrons introduced to sphere B until sphere B changes from 6, which is positive, to minus 3.3. Do we agree? Before we continue, I just want to ask, can you explain, Ronald, can you explain how the electrons moved in this setup? They moved from which sphere to which sphere until we reached equilibrium?
So what do you mean? Like,
what I mean is, did the electrons moved from sphere B to C, or did they move from sphere A to B, or what happened? Can you explain how the electrons moved?
so I think in terms of all three of them, so I would have guessed that sphere A and C move towards sphere B.
Mamson, do you agree?
Yes, I agree.
That is true, because from sphere A, minus 2 times 10 to the power of minus 11 changed to 3.3 times 10 to the power of minus 12, if I'm not mistaken, which is lower than the initial charge. It means there were some electrons that were reduced and they moved to B, but a little bit. But a lot of electrons were moved from C to B. But electron moved from A to B and also from C to B.
Okay, so in my answer, I was
Yes.
just using general knowledge because I'm thinking because sphere B is in the middle, I would assume like from common knowledge or common sense point of view that A and C would move towards sphere B. So is there ever gonna be a case where for example B and C move towards sphere A?
And before I answer you, B and C didn't move to B and C didn't move to sphere A. Ne?
Yeah, I'm just saying, is there
Electrons. You're talking about electrons.
okay?
Electrons are the ones that are going to move from sphere A to B. Because if you use the terminology that you're using, they may not give you marks. If you say the sphere A moved to B, that's incorrect.
Okay.
Yes. So we talk about electrons. Ronel, does protons move?
So is this a trick question?
Okay.
So I would. I'm gonna say no, sir.
Okay, Mamsan, what is your answer? Do protons move?
Photons do not move.
That's correct. Protons don't move. Only electrons move. So there will be cases whereby you will find electrons moving from A to C and also from B to C. Those instances are possible depending on what the situation is. For instance, let me give you few examples. A, B, and C. Let's say if B is, say, that's 2 microcoulombs, and C is minus, say, okay, so if C is 0 coulombs, if it's neutral, and let's say if A is 5, minus 5 coulombs. Okay, Ronel, where will the electrons move? From which sphere to which sphere?
So would they not, would A and B not move towards C?
A and B, you're saying A and B will move to C, but let's see if that's the case. So Q nu will be equals to minus 5 minus 2 plus 0. Do you agree?
Yes, sir.
Okay. So this will be minus, what would be the answer?
So everything would give us negative 2.33.
Aha, I love this. I love, yes. Okay, yes. You said electrons will move from A to C and also from B to C, right?
Yes, sir, that is what I said.
Do you still stand with the same answer?
No.
Mamswan, do you agree with Ronawa's answer?
I don't know. Yes, I think I would agree.
The answer is not correct. You cannot predict the movement of charges without computing the Q nu, because the Q nu will show you how much each sphere will have at the end. Do you agree?
Okay, sir.
Yes, sir.
And then,
Ronel,
okay, so I understand. So what would the answer be if they were asking which spheres are moving towards which one? Once
okay,
we've gotten our answer.
okay, okay. You can see that initially we had 2, right? On sphere B, we had 2. You agree?
Yes, sir.
And then after contact, we had 3 minus 2.33. Did we get an addition of electrons or a subtraction of electrons?
So we we got more electrons.
So do you see that electrons will be transferred to A, from A to B, and also a lot of them will go to C. A little portion will come to B, and then another portion will go to C.
Yes,
Mamswan, do you agree?
Yes, sir.
Yes. So a whole 2.33 coulombs of electrons, microcoulombs of electrons, will go to C, and then 0.33 microcoulombs will come to B. So we're gonna be left with, if 0.033 is gone, minus another 2.33. Can you use a calculator? We want to see how much we're gonna have. How much are we gonna have?
Negative 7.66.
Negative 7. 5 minus these two.
Oh, but isn't your Oh, okay, wait.
Yeah, actually, I just want to check how much, how many microcoulombs are we left with after?
Oh,
Yes, these two are gone.
2.34.
2.34. It's basically 2.33. So we're gonna be left with 2.33, and then 0.33 will come out of this 5 to add on top of 2. Then we'll have 2.33. You agree?
Yes.
Yes, and then on C, 2.33 will go towards C. Then we'll have 2.33, 2.33, 2.33. That's how it works. So the bottom line is, you cannot explain how the charges will move without computing Q nu all the time. You need to know how many electrons are going to be transferred by calculating how much will each sphere have after contact. Then you will know how much was reduced and how much was added. Are we all in the same page? Do you have any question?
No.
On electric fields, Ronewa, do you still have any question?
no, sir.
Okay, so in the next lesson, we're gonna be doing electric field problems, some electric field problems. But I'm also glad on the fact that we have already done some of the electric field problems in our assignments. So I feel like you guys are way ahead of the teachers by far, which is good. Which is good. Mom Swan, when are you guys writing the test?
I am writing physics on the 19th.
The 19th is most next week. Next week, Wednesday.
Yes.
And the topics?
It's gonna be Newton's law, Newton's gravitational thingy, electrostatics, and what is it? Vectors. The one with the vectors. I forgot the topic. The name of the topic.
Vectors in 2D.
Yes. Vectors in 2D.
Oh.
Yes, so we're writing on the same thing, just on different days.
Oh, okay. Okay. I just can I explain something quickly?
Sure.
Yes.
Okay. Have you guys done, have you guys ever solved forces using triangles?
Yeah.
Yeah.
Yeah, we have.
You have. Which method do you find comfortable? Using triangles or using Newton's law?
Newton's law is better for me.
Yeah, so I don't like mixing maths and physics.
Oh, okay. Then I was gonna try to touch it, but if you're comfortable with the Newton's law method, then it's fine because the triangle method has exceptions. You can use it. You can use it. Okay, when can we not use it, Mam Swan? The triangle method.
Uh, so I think if there is your force is not acting on an inclined plane or something like that, or it does not have so there's a diagram in front of me, so I don't know how to explain.
Okay, Romeo, what is your answer? When can we not use it?
I don't know because I never use it. So
Okay. We can only use this method if your forces are in equilibrium. Let's say if there was a rope holding an object, two ropes holding the object, obviously there will be a force going in that direction, which is tension, and there will be another force of tension also, T1 and T2. Also, here there will be a force of gravity. So if you have been told in the test or the exam that your system is in equilibrium, then you can use the triangle method as you please, because this is what you're gonna do. You're gonna transfer T1. You're gonna transfer force of gravity. Then you're gonna transfer T. Sorry, this is T2. You're gonna transfer T2. This is T2. Then you're gonna transfer T1. It will maintain the same direction. This is T1. So you can only do this if your forces are in equilibrium. If there is no net force, if there is no acceleration of the system in any direction, then you can use the triangle method. But otherwise, you can use Newton's law wherever, whenever. So the other thing that you must take note of is that this method works only when there's three forces. That's another condition. Another observation, do you guys have any other observation that you are seeing on the diagram I've constructed in this one? Do you have any other observation? Okay, the other observation is that your arrows will form a circuit. Meaning your arrows will, the head of one arrow will join the tail of another arrow, and the head of another arrow will join the tail of another arrow. That is always the case when you are dealing with equilibrium cases. So you might get three options in your multiple choice, whereby they will be asking you which diagram corrects represent an equilibrium system, like the one here. So this is correct, or this can also be correct. If I transfer this force of gravity, because it's going down, if I transfer T1, so if this is T2, as long as they maintain the directions, T1. Please note, now your system is moving in an anti-clockwise direction. However, the head of one arrow is joining the tail of another arrow. The head of another arrow is joining the tail of another arrow. Here, your system is moving clockwise. So the two diagrams will yield the same results. However, the head of another arrow must join the tail of another arrow. I think that's what I wanted to emphasize. Is there any question concerning that?
No, sir.
Okay. So I'll see you guys on Thursday. Today's what, Tuesday, right? Yes. So I'll see you guys on Thursday. And good luck with your tests. Rodney, good luck with your test.
Yes, and I need it.
Okay, so no problem. I'll see you guys on Thursday.
Okay, bye.
Bye.
Bye. Mapula baba twagila lava butsi sama imunyaga umbiwa ulombiga da inde unyaga umbigiwa uklombiga da inde unyaga mapatini udlevari itwa amapula baba twagila lava butsi sama udlevari itwa amapula baba twagila lava butsi sama imunyaga umbiwa ulombiga inde unyaga umbigiwa ulombiga inde unyaga mapatini udlevari itwa amapula baba twagila lava udlevari itwa amapula baba twagila lava sama inde unyaga umbigiwa ulombiga inde unyaga umbigiwa ulombiga mapatini udlevari